Our final related rates problem is gravel falling on a conical pile. This is a very common related rates idea. So we have this gravel, it's falling on a pile at a rate of 10 feet cubed per minute. And at all times, the radius of the cone is twice the height of the cone. Find the rate of change of height of the pile when the radius of the pile is 6 feet. Then we have to write a sentence explaining the meaning of our answer. We forgot to do that in the last video, but I did say it, so we probably should write it though this time. Okay, so gravel's falling on this pile. So we already have a picture there, so let's go ahead and label this picture. So this would be the height of the pile, and this is the radius of the pile, right? And in this case, we would normally be given the volume of a cone. So we know that the volume of a cone is 1/3 pi r cubed h. Okay, and so let's figure out what we're trying to find and what we've been given. So we're given that gravel is falling at 10 feet cubed per minute. So what does that mean? Well, feet cubed gives me the idea that this is volume because that's a cubic measure. And so I have to think about what is actually changing. Well, that means the volume of the pile is changing by 10 feet cubed every minute. So I know that the rate of change of the volume with respect to time is 10 feet cubed per minute. And then it wants me to find the rate of change of the height. So I need to find so there's our givens. Find the rate of change of the height. So dh dt when the radius is 6 feet. Now the first thing you want to do is we're going to set this up. So we know that this is how the radius, the height, and the volume are all related, right? We can go ahead and differentiate. So we have dv dt equals 1/3 pi. Those are all constants. But then we've got this really icky product, right? So this is going to end up being 3r squared h. So that's the derivative of the first times the second plus the derivative of the second. The derivative of the first, dr dt, times the second plus the derivative of the second, which is dh dt, times the first. And we're like, ugh, okay, well, I could plug most of this stuff in, right? I know dv dt. I know the radius. I know how the radius and the height are related, but guess what? I'm trying to find dr dt, but I don't know dh dt, do I? I don't know dh dt. Oh no, I'm trying to find dh dt. I don't know dr dt. Oh man, I'm all backwards. Okay, I'm trying to find this, don't know this. And there's no way for me to figure that out. So what if I went back to my original function and I related r and h to begin with before I did any of this mess? Okay, so I got to a mess and I went, that doesn't work. So I come back and I say, okay, well, at any given time, I know it says at all times the radius of the cone is twice the height of the cone. So the radius always equals 2h. Always, okay? I'm trying to find dh dt. So wouldn't it make sense that I'm in terms of h and not in terms of r at all? Because if I know that at all times r is the same as 2h, everywhere I have r, I could just replace that with 2h. So I'm going to replace it here, and I noticed that I have a typo, and you probably all noticed it. You were screaming at me through your computers, Mrs. Barney! That should be r squared. Okay, so now I'm going to replace, everywhere I see an r, I'm going to have replace it with 2h. So I have 1/3 pi, and then instead of r, I'm going to have 2h squared h. So I'm just going to simplify that. So I have 1/3 pi 4h to the third. And so I can just say this is 4/3 pi h cubed. And that's so much easier to differentiate than what we had before, right? Because we don't have the product rule anymore. We just have one variable. Now we're going to differentiate. So we have dv dt equals 4/3 pi 3h squared dh dt, right? Because we're with respect to time, since none of these are time, all of them are implicit. We always have to tack on that derivative. Okay, so I can simplify that some more. So I have dv dt equals 4 pi h squared dh dt. This is what I'm trying to find, right? So what do I know? I know dv dt. It says that dv dt is changing at 10 feet cubed per minute. So this is 10 equals 4 pi h squared dh dt. And then what about h? Well, do I know h? No, darn it, I'm trying to find dh dt when r equals 6. So how do I find what h is when r equals 6? Well, they're always related, aren't they? So if r is 6, h has to equal 3. So I can come back down here and I can say 10 equals 4 pi, 3 squared is 9, dh dt. So I have 10 equals 36 pi dh dt. And I'm still trying to find dh dt, so I've got to divide both sides by 36 pi. So I have dh dt equals 10 divided by 36 pi. And that's about it. We can go ahead and label that as feet per minute. And we could notice that we could simplify that. So we can dh dt would be 5 over 18 pi feet per minute. And again, since this is a real world problem, you want to put the exact answer like that. But we could also give ourselves, let's see, 5 divided by, I got to put it in parentheses. There we go, 18 pi. We could give ourselves a decimal if we wanted. I wouldn't just put the decimal. I would put them both. Always have the exact answer, but and also do not use an equal sign. So dh dt is approximately equal to 0.088 feet per minute. Since it's a real world problem, it's always good to have that. You don't have to exact and then decimal as well. So what does this tell us? We just found dh dt, and what does that mean? Well, dh dt is the rate of change of the height, of the pile when the radius of the pile is 6. Go back to your problem and use your problem to write your sentence, okay? So, the rate of change of the height of the pile when the radius of the pile, you know what, I think I'm gonna, I will say it, my English wasn't very good there. The height of the pile is, let's do that, the rate of change of the height of the pile is 5 over 18 pi feet per minute. And that's when we'll say when the radius of the pile is 6. Because remember, the rate of change of that height is constantly changing. So I have to tell when I'm talking about the rate of change. So the rate of change of the height of the pile is 15 over 18 pi feet per minute when the radius of the pile is 6. I would always use the exact one in this, especially if you're saying is. If you say is approximately, if they ask you for a decimal, you could say is approximately, but never say the rate of change of the height of the pile is 0.088. It is not 0.088. It is approximately 0.088, but it is not 0.088. So that would be our final answer, telling what the rate of change of the height of the pile is when the radius of the pile is 6.